Welcome to the Explainer. Today, we're diving into a really big question in AI. How do you build a system that doesn't just work for a demo, but actually lasts in the real world? Well, the answer comes down to a super powerful idea called modular design. Okay, let's just get right into it. Look, with the tools we have today, anyone can whip up a simple AI agent that does a basic task. That part's getting easier and easier. But the real challenge, the thing that separates a cool weekend project from a serious, production-ready system, is building something that can grow, adapt, and not completely fall apart under pressure. So, how do you build an AI that's truly built to last? So, at the very heart of this problem is a big choice you have to make about how you build things. On one side, you've got the monolithic approach. Just think of a sculptor carving a statue from a single, giant block of stone. It's all one piece, tightly woven together. It can be powerful, for sure, but it's also incredibly rigid. One crack, one mistake, or even just the need for a small change, and the whole thing can crumble. But then you've got the other way, a modular design. And this is more like building with Lego bricks. Each piece is its own independent thing, but they're all designed to snap together perfectly to create something bigger. And when we're talking about AI agents that have to survive out there in the messy, unpredictable real world, well, that Lego approach isn't just a nice to have. It's everything. The future of AI that can actually scale is going to be modular. It just has to be. So, what do we really mean by modular design? At its core, it's a strategy. You take a really complex problem and you break it down into smaller, bite-sized, self-contained pieces. Each little module has one specific job to do, and they all talk to each other to get the big picture task done. And this approach, it unlocks some serious superpowers. First, specialization. Each module can become an absolute expert at its one job. Then there's scalability. You can add new features or handle more users just by adding new modules, without having to redesign the entire system from scratch. Maintainability is a total game changer. If one part breaks, you can fix or replace that one part without bringing the whole system crashing down. And finally, reusability. You build a great component once, and you can just plug it into other agents later. That saves a ton of time and effort. Okay, so that's the theory, right? But what does a modular agent actually look like on the inside? Let's pop the hood and take a look at its anatomy. A really robust modern AI agent can basically be broken down into a core team of 5 specialist modules. Think of them like a high-performance team where every member has a very distinct, very critical role to play for the mission to succeed. And here's how that team works together. The orchestration engine, that's the project manager, the brain of the whole operation, deciding who does what and when. The prompt engine is like a master communicator, crafting the absolute perfect instructions for the language model. The knowledge base is your expert librarian, with a perfect memory, fetching any data you need in an instant. The tool library is your skill technician, the one with all the tools to connect to the outside world through APIs. And finally, you've got the observability module. That's your quality inspector, always watching, logging, and making sure everything is running smoothly. But here's the thing. We can take this whole idea of separation and push it even further. To really, truly unlock the power here, we need to give these parts real independence. And this is the mental shift that changes everything. You stop thinking of these modules as just connected parts of one big program. Instead, each one becomes its own tiny independent service, a microservice. It runs all by itself, it talks to the others through a really clean, simple API, and it's completely self-contained. And when you do that, the benefits are just incredible. First, technology independence. Your team working on the knowledge base can use Python because it's great for data, while the tool library team can use something else that's better for fast API calls. You use the best tool for the job every time. Then there's independent scalability. If your agent is suddenly getting slammed with requests that need a specific tool, you can just scale up that one service without touching anything else. It's so much more efficient. And maybe most importantly, fault isolation. If one of your tools goes down, it doesn't take the entire agent down with it. The system stays up. It's resilient. So what's the big picture here? What's the blueprint we should all be taking away from this if we want to build AI that actually works in the real world? It really all comes down to this one idea. Modular design isn't just some fancy pattern or a best practice. It's the essential blueprint. It is the architectural foundation you need to build on if you want something that can grow, that's easy to fix, and that's tough enough to handle the chaos of a real production environment. This is how you build an agent that actually lasts.
And that leaves us with a really fascinating thought to chew on. We've just talked all about how the best agents are built from these specialized, independent modules. So, what's the next step? What happens when these super capable modular agents themselves become the Lego bricks for something even bigger? A whole ecosystem of intelligent systems all working together. Now, that is the frontier that this approach opens up.